Hi, everybody. Welcome to topic number 10, empirical rules and standard scores. So in the next few topics, we will talk about probability. So after rules and standard scores. So what is an empirical rule? Well, if a data has a distribution that is bell curve, okay, like we mentioned before, skew right, skew left, and we have one that's called the bell curve shape, which is another word for normal distribution. We will use this word later on. Okay, so if the data has a distribution that is bell curve shape, we can use what we so-called empirical rule to determine the percentage of a data that will lie within K so many standard deviations of the mean or to the mean. So empirical rule determine the percentage of a data that will lie so many standard deviation of so many standard deviation so many standard deviation to the mean. Okay, so if I have a bell curve shape like this one, the mean always lies in the middle. Okay, the mean is in the middle. So one place to the right, to the left of the mean is 68% of the data. 68% of data lie within one standard deviation to the mean. Okay, two standard deviation out is 95%. Okay, 95% data are within the mean. So here are the breakdowns. So all these percentage are the breakdowns. Okay. And then three standard deviation out, that will be 99.7% of data. Okay, within the mean. So the corner right here, each end does not end. It keep on going forever. Okay, this kind of continuous curvature. All right. So so the picture is real good. It breaks down individual individual section. Okay, so we will use this picture here in a minute, to answer a lot of questions. All right. So the empirical rule tells us the percentage of data that will lie within so many standard deviation to the mean in the middle. All right, so let's try some examples. Suppose the IQ scores have a bell-shaped distribution. So we got to make sure it's bell-shaped distribution first before we can use an empirical rule with a mean of 97 and a standard deviation of 18. Using the empirical rule, what percentage of an IQ score are greater than 151? Okay, so let's draw the picture. So if the mean in the middle, he told me is 97. So my X bar is 97. Standard deviation is 18. Okay, what percentages score are greater than 151? So my X, okay, this X is 151. I purposely write this, this is also what we so-called a random variable. I'll introduce that word later on. So I don't really need to know this, this X, but I want to put a notation down here. 151 is to the right of your mean. So maybe somewhere here, I don't know. Okay, greater than, we're trying to find a percentage of IQ that is greater than 151. So that will be to the right side of 151. So this part is what we're looking for. This percentage is what we're looking for. Okay, so 151 is how many standard deviation away? Well, let's see, X bar plus 97 plus the standard deviation. So I'm going to the right. So if I'm going to the right, I will add. So 97 plus the standard deviation 18 one time. 115 is one standard deviation to the right. So if I plus another 18, then that's 133. So that's two standard deviation to the right. So if I plus 18 one more time, that will be 151. So they tell me that 151 is three standard deviation to the right. So 3 times the standard deviation. So mean plus 3 times the standard deviation, 18, will give me 151. Okay, So this 151 is 3 standard deviation, and I'm looking for percentage greater than that. So let's go back up here. 3 standard deviation, 1, 2, 3. So the 151 is basically right here. The 151. Okay. So I'm looking at greater than 151. So greater than 151 is only 0.1%. So my answer is 0.1% of it. So the percentage, so what we're saying is percentage of the IQ score that are big greater than 151 is very, very, very small. It's only 0.1% of the data of the score can be higher than 151. All right, let's try another one. All right, suppose that GPA at or at a university have a bell-shaped distribution with a mean of 2.61. Okay, so my mean 2.61 with a standard deviation 0.4. Use the empirical rule, what percentage students GPA that are between 2.21 and 3.01. Okay, they are in between 2.21 and 3.01. Okay, so let's see. The mean in the middle is 2.61. 3.01 is to the right. 2.21 is to the left of the mean. So if I take my X bar plus, let's give it a try, okay? 2.61, right? Plus 1 standard deviation, 0.4. That will be 3.01. So 3.01 is only 1 standard deviation away. 2.21 is to the left. So 2.61 minus 0.4. Okay, 2.21 is to the left of your mean. So 1 standard deviation. So the 2.21 is 1 standard deviation below the mean. Okay, so I'm looking for the percentage of students that have a GPA that's between these two. So I'm looking for the percentage that's in between. So this is the area I'm looking for. The percentage in between those two. So 1 standard deviation. Since I'm only 1 standard deviation away, right? 2.21, 3.01. Since I'm only 1 standard deviation away from the mean, so all this place, 34% plus 34%. So that means the percentage that are in between is 68%. Okay, that's how we actually find those. Right, 1 standard deviation weight is 68% of the data, like within, there's 1 standard deviation within the mean. So that's 68% of the data. All right, suppose the IQ score have a bell-shaped distribution with a mean of 96, so X bar 96. Standard deviation of 14, right? Remember the notations that I introduced in the previous topic. X bar is simple mean, S is simple standard deviation. Use empirical rule, what percentage of IQ score is no more than 110? So X is 110. All right, so mean 96, all right? 110 is to the right, so we just need to figure out how many standard deviation away is 110 to the mean. 96 plus standard deviation 14 is 110. So there's only one standard deviation to the right. So the wording, okay, no more than 110 means to the left of 110. So all the percentage to the left side of that 110 is what I'm looking for. Okay, so there are two ways we can go about doing this. Once you established which side of the, which side you're looking at of that 110, right? In between, the first one was greater than to the right. This one is in the middle, second one is in between. This one here is no more than, so that's to the left of it, of that 110, of that X. So two ways to go about it. So my 110 currently, my 110 is right here, 1 standard deviation. And all this, no more than all this percentage to the left of it is what I need. Okay, so there are two ways we can do this. We can add them up, 0.1, 2.4, 13.5, 34, 34. We can do that, add them all up to get our answer, or we can take 100% and subtract what we don't want, which is to the right of it. 100% is the total. Subtract what we do not want, which is the right side of it. That will give me what I want, which is all these percentage to the left. Okay, so if I add up what I do not want, 13.5, 2.4 plus 0.1 is 2.5 plus 13.5. What the percentage I do not want is 16%. So what we can do is take 100% minus what I don't want, the 16%, and the 16% come from the 13.5 plus the 2.4 plus the 0.1%. Right? So the percentage to the line that lies to the left side of 110, my X is 84% of the data. Okay, so 84% of IQ score are no more than 110. That's what it means. Okay, so this technique that I just did to figure out the 84% is also what we call the complement rule. Okay, the complement rule. Figure out what you don't want, subtract from 100% to get what you want. All right, let's try another one. Suppose that a diameter of a new species of apple have a bell-shaped distribution with a mean of 7.2 centimeter. So this new species of apples have diameter 7.2 centimeter, standard deviation 0.38. Using the empirical rule, what percentage of the apple have diameter are at least 6.44? At least 6.44. Okay, so 7.2 is right here in the middle. That's the mean. 6.44 is to the left. Okay, so let's see how many standard deviation away. So I will minus this time, right? To get to 6.44, I have to subtract from the mean. So 7.2 minus 0.38. That is 6.82. One standard deviation. So subtract another standard deviation, 0.38, 6.44. So 6.44 is 2 standard deviation below the mean. So 2 times 3.38. Okay, at least, what does the word at least means? Well, think about, I have at least $10 in my pocket. That means I have $10 and more. So the percentage I'm looking for is to the right of 6.44. Okay, so the 6.44 is 2 standard deviation below the mean. So 2 standard deviations right here, 6.44, right? And the percentage I'm looking for is to the right of that, all this. So once again, I can add them up, 13.5, 34, 34, 13.5, 2.4.1 to get my answer. Or I can use that complement rule again, right? What I don't want is to the left side of 6.44. I don't want 2.5%. So I can take 100% minus what I don't want, which is 2.5%. And this 2.5 comes from that 2.4 plus the 0.1 to the left. That's right. The area or the percentage I do not want to the left side of 6.44, right? This part is 2.5. So I take 100%, subtract what I don't want to get what I want. So my answer should be %100 minus what I don't want is 2.5. So that would be 97. 0.5%. Okay. All right. So that's how we actually use the empirical rule. So these words are highlighted. Okay, we will actually come back, talk more about them after the next several topics on probability. All right. So keep this topic in mind. We'll actually come back to this. Same thing with this thing called the standard scores. Okay. The z-score is a distance that a data from the mean in terms of standard deviation. How many standard deviation away? Okay. Positive z-score means data is larger than the mean. Negative z-score means the data is the negative z-score means the data is smaller than the mean. So think about this. Okay. The example we just did, we keep on referring back to the same picture, right? So one standard deviation above the mean, right? 2 standard deviation above the mean, 3 standard deviation above the mean. 1 standard deviation below the mean, 2 standard deviation below the mean, 3 standard deviation below the mean. Okay, so all the numbers that we just came out with, all the number we came out with is either 1, 2, or 3 standard deviation above or below the mean. So that means in a different axis, this is called the z-axis, where we standardize every single problem. What we're trying to do is standardize every single problem. Is always going to be 0. Okay. So think about this 151 earlier. We know 151 was 3 standard deviation above the mean. Okay. So we can use this formula down here. Okay, I got 2 of them. One of them is for population, one for simple, right? So if you look at the simple, we take the x, we take the 151, subtract the mean, divide by standard deviation. That will tell me that 151 will be how many standard deviation away in terms of standard deviation, basically. The subtraction in the formula means the distance to the mean. Okay. So think about this. 151 subtracts 97. Is 54 places, right? So 151 is 54 places to the right. So if I divide it by the standard deviation, which is 18, that will tell me the 151 is 3 standard deviation above the mean. Okay, that's what z-scores are. Okay, that's what a z-score is. It's telling me the number I'm given, okay, is how many standard deviation away from the mean. You standardize every single problem we have into the same axis, okay? So we look at it in terms of standard deviation. So consider a set of data in which a simple mean is 37.2. So simple mean 37.2. Oops, sorry. Standard deviation is 6.5. Calculate the z-score given x is equal to 29. So a lot of students don't understand what x is. X is your random variable. Okay, that's the variable I'm trying to convert. That's the given I'm trying to convert into some, trying to figure out that 29 is how many standard deviation away. So again, like I said, this topic right here will be continued talk about after we go through the probability part of this course. Okay, this is very important. So the z-score, okay, if you look at the formula, x minus x bar, x is 29, that's the number I'm trying to convert, minus standard deviation, excuse me, minus the x bar divided by standard deviation. Okay, so 29 subtracts 37.2 first. Subtract first, then divided by 6.5. So remember now, 29 is below the mean 37.2. That's why my answer is negative. Negative z-score means your given is below the mean. It's to the left side of the mean. So when we calculate z-score, we always round to 2 decimal places, always, negative 1.26. Okay, so this number means 29 is 1.26 places, 1.26 standard deviation below the mean. Negative 1.26 is just slightly right below 1 standard deviation. Okay, so you ask, okay, Mr. Chan, how do you find the percentage when how do you find a percentage of those numbers if it's not exactly 1 standard deviation, 2 standard deviation, 3 standard deviation away, right? How would you find if negative 1.26 is right here? Then how do I find percentage that is either to the right or to the left of it? Well, that's why we have other topic we're going to introduce how to do that. Okay, so stay tuned, stay tuned. All right, let's look at your homework. Okay, question one is from the definition. Number two, suppose that IQ score have bell-shaped distribution with a mean of 101 and a standard deviation 12. Use empirical rule in the lecture handouts. What percentage IQ are less than? Be pretty accurate. And this one is in between, just like I did earlier. And this one is calculating the z-score. So this question number 4 is like this last one I did. Okay, round to 2 decimal places, please. All right. So just real quick, talking about what the empirical rule is and how we can actually find what we so-called a standard score or the z-score. Basically, standardize all the given information, and then calculate them in terms of how many standard deviation away from the mean. All right. Thank you for watching.